Morning, everyone. Good afternoon, good evening, wherever you're connecting from in this wonderful time of not being able to travel anywhere. There's folk attending these conferences from all around the world, which is a lot of fun. Myself, I'm up in the north of England in a little town called Ilkley. It's set in this beautiful surroundings of Wharfdale, and it's lovely, and there's lots of countryside, and it's this little town nestled away. It's got a few facilities, it's got a few schools, a few shops, but for kind of like bigger shops and things like that, we have to head to our nearest town, our nearest city, which is a place called Bradford. So this being a London conference, I'm guessing it's a few folk who will at least know rough geography of where I'm talking about. So sometimes I go into Bradford and sometimes I'll drive there. And we drive into Bradford and you'll need somewhere to park your car. So up here in West Yorkshire, we'll look for a car park. Elsewhere in the country, they'll probably say car park. But we look for a car park, and we're wondering things like, well, where is my nearest car park that's got somewhere for me to park in? Or there's a particular car park that I've got in mind. I wonder how many spaces are available. Or all the car parks seem to be completely full up, which is kind of pretty unlikely at the moment, but maybe it'd be useful to find out, get an alert when there is a car park that becomes available. And being a bit of a data geek, it's always interesting to kind of like analyze these things and look at how occupancy varies over time. So my name's Robert Moffatt. I'm a developer advocate at Confluent, and Confluent are one of the companies that contribute towards the open source Apache Kafka project, and we have our own managed Apache Kafka in the cloud called Confluent Cloud. So today I want to go through an example of some of the things that you can build using Kafka and a thing called ksqlDB, but building around this idea of car parks and kind of like building a useful app around that set of data. Now, there's an open API for this source of data. Now, as the demo gods would have it, that API seems to be a bit stuck at the moment, so it's reporting old data. But I managed to find another one that we're going to add in there also. But my primary source of data is this one from Bradford City Council, and they publish this open data, which is great. And you can actually pull that data in, and you can find out information in near-ish real time about the state of the car parks, how many car parks are occupied. What we're going to do is we're going to hook it up to a tool called Telegram. So Telegram, if you're familiar with it, you'll know what it is already. If you're not, it's kind of like WhatsApp or Facebook Messenger. It's just kind of like one of these messaging tools that's become rather popular in recent years. And it's got a rather good API to be able to create bots against it. So you can automate interactions within it. So it's a useful little front end. So we're going to write a custom app from scratch to interact with users. We're just going to hook into this. All sounds very fancy. I want to show you in action first what we've built, and then we're going to walk through how we've built it, some of the interesting design patterns that we've implemented using it, and talk a little bit about Kafka and why that kind of fits into the picture here. So let's actually go and have a look at that. What is my Telegram bot over here? And on the left-hand side, we've got the bot itself that's running in the back end. So I'm going to start the bot. So on the right-hand side, you click on Start. So I'm using Telegram from my computer. If I'm driving along in my car, I guess my passenger will open up their phone and use Telegram from there. It's got lots of different devices it can use from. On the right-hand side, we've sent a start command to the bot. And we can see in the back end in the bot, it's received this message here. It's received it from a user, and it's a /start. So then the bot itself has sent over this message telling me how to go and use that bot. So we could do things like, I would like to go and look up how many spaces are available in a particular car park. So I'm going to say, let's go and have a look at a place called Westgate. And it's going to say, okay, in this particular car park, there's this many spaces available. Now, as I said, this API at the moment looks to be jammed. So I was trying this out earlier, and I was like, oh no, I've done something wrong. My thing's broken. But it turns out the API itself it's got some stale data. So it's 2:30 this morning. Something went bang in someone else's system, not mine, fortunately. So we've got some stale data. So I've got another car park that I'm going to look up, and it's called this one here, Wellington. I'm going to take that, and we're going to stick that in there instead. The name's doesn't really trip off the tongue, this one. This is more of a kind of like system-based name, but this is to do with car parks based in Leeds. So we've got data from car parks in Bradford, and then Leeds, another West Yorkshire city. And you can see this one here is 10:20, 55 seconds. That's basically like, as of now, give or take a few minutes. So this car park here, it's 73% full. We've got this many spaces available. So that's quite useful. We've got a little front end on our app, and we're making requests against the back end, and we'll look at that back end in a moment, saying, what's the current state? How many spaces are currently available? But we could also do things like this. We could say, well, here's where I am at the moment. So I'm going to send this location over, and it's going to find out which is my nearest car park that has got some spaces. At the back end here, you can see it's actually sending over a SQL query, and it's doing like latitudes and longitudes, and it's taking my location information. It's saying, well, we know about all the different car parks, and we're going to look up and find out which one is closest, like as the crow flies, to this person. So it's come back with all of these different car parks here. It's worked out which one's closest. It says, well, the nearest one is Westgate here, which is the one in Bradford, and it's 14.4 kilometres away. So that's also pretty useful. The other thing we could do is you could say, well, let's imagine that we weren't in the midst of a pandemic. Let's imagine the car parks are really full because people are actually going places. And so I've tried to go to a car park. All the car parks are full, so I'm going to set an alert. Tell me when a car park becomes available that's actually got some spaces. Now, because this is live data, and because all car parks have got lots of spaces at the moment, I'm going to cheat a little bit. Imagine that it's me and 999 friends. So actually we need 1,000 spaces free. If I put like one space, then all the car parks are going to come back and we'll get like a bunch of different alerts. So let's say, tell me when a car park becomes available with more than 1,000 spaces in. So now it's going to tell me when a car park becomes available with more than 1,000 spaces in. So now we get the event-driven alert side of things. So if a trigger, we've set a threshold, and when it receives a notification, like it just did then, that like this car park's reported in its data, it's okay, this car park here, it's gone over that threshold, it's got more than 1,000 available, so it tells the user about it. And you can see this in the back end here, it's actually written using SQL statements to express it. So that's the kind of thing that we've built in terms of the Telegram bot. Now, I'm going to go and kill the bot at the back end here, otherwise we'll keep on getting notifications during this talk, which will be kind of distracting. The thing that I've built out using this same stream of data, and as I say, we're going to have a look at the back end in a moment, is building some analytics around it. So for this, I've taken that data, and instead of kind of manifesting it out through Telegram itself, instead we're streaming that same data into a backend store. I'm using Elasticsearch here with Kibana on top to build ourselves a nice little real-time dashboard. So you can see here, we're looking at data for the last like 9 hours or so. You can see here at 2 o'clock this morning, we had data from lots of different car parks. And then that Bradford car park feed kind of went offline. And so now we've just got data coming in from the Leeds car parks. And you can see it's about 6 o'clock this morning, people start driving into Bradford city centre, because obviously some people are still out and about working, kind of like frontline workers. So you can see the car park occupancy starts to increase and it goes up here. People start to go and park their cars. I'm sorry, take a few cars out. And over here, the number of spaces available goes down as more and more people go in to park. We can plot it on a map. So we've got the geolocation information here. So if we zoom out, we can see we've got car parks in Bradford, we've got car parks in Leeds. So for those of you who kind of like have a very a southern view of the country, here's London down here, and here's Leeds and West Yorkshire up here. Now we can zoom back into that, and we can also do useful things with the data. We can say like, I'm just interested in a particular area. So we can actually draw a shape to say like, just tell me about car parks within this bit of Leeds here. So we're going to click on there, and hopefully that's going to build ourselves a little vertex around that. So now we're filtering the data. Now we can zoom in on that a little bit. It says, well, here are the car parks just within the Leeds area. So now we can look at those. We've got a little hotspot, a little heat map showing which car parks have got the most spaces available and so on. So a bit of fun that you can do with the data. It's actually quite interesting to analyze it. If you zoom all the way out, in fact, let's just do that because it is actually pretty interesting. So let's get rid of that filter. We can actually look at the data historically. So say, let's look at the data for the last, I think, about 2 years worth of data and apply that. And you can see what happens back here. So this is the number of empty spaces. So the lower the number, the more spaces are occupied. And you can see this is what it looked like in before times. And then we go along here and we got this time a year ago. And then we got the UK lockdown in March last year. And then since then, just like loads and loads of parking spaces because people weren't going anywhere. And you can see it eased off a bit in the summer, and then we locked down again, and suddenly no one was parking anywhere. So the data that we've got here is pretty interesting. I find it interesting anyway. You can use it for doing analytics and build it out with dashboards like this. You can also use it for driving applications. So let's close that down, and let's actually go and have a look at what we've built here. So oops, not on that one. I'm actually going to have a look at the things itself. Let's take a step back from kind of like the demo itself and the graphs and stuff like that, let's go and have a look at the Telegram piece to start with. So I want to show you the Telegram bot. It's written in Go. So Go was a project of mine to learn last year. It was like, I was going to say it was lockdown, we had loads of time. I've got 2 kids, I don't have loads of time. I didn't get to go and watch all the box sets on Netflix, but I did get to go and teach myself Go. And if we're going to have a look at the code for the Telegram bot, we can have a little look through how it was done. Now, as I say, I've just taught myself Go, so there were probably a bunch of errors in this, but hey, it works, which is just about good enough for me. So within the Go routine, we can see we pull in the Telegram API. It's a nice third-party library that someone's written wrapping around the Telegram API. And then we authorize ourselves to the Telegram service. So when you want to write a Telegram bot, you go to something called the bot father. It's got a little Godfather style icon. And you say, I'd like to create a bot, and it gives you an API token. So we put our API token in there. And there's a bit of log information. So we've authorized on that account. And then we say to Telegram, I would like to subscribe to a channel of updates. So anytime someone sends a message to my bot, I would like to receive that update. And then we just loop. We say, let's kind of like sit here until we get an update. Updates come through in different forms. So you get the message text, and you get the chat ID, and then you get different types. So we've got a switch statement here, which goes through the different types of messages you can get. You can get a command. So like /start is a command, /alert, like we saw with the car parks saying like when there's more than 1,000 spaces, that's also a command. So you can say, well, based on the type of command, we're going to send a different thing. So if we send start or help, send them a sarcastic message. If they say alert, like this is just like a boilerplate thing that I put together before we put all the actual car park stuff into it. So testing out the different types of commands. You can also say, well, if you send through a location. So the location bit looks like this. So the type of location it comes through, and it's not null. So you say, okay, we've got the location, and we can do some processing based around that. And if they've not sent us a location or a command, in our case, we're going to say, right, well, we'll just default to this. But you can also do things like handle files, and I think it can also do some kind of payment things. But we're just going to say, if it's not a command, if it's not a location, then we'll just echo it back to them and send them a copy of what they sent us. So this is actually kind of like the shell for building the Telegram bot. And then around that, we just write some more code which hooks out into that backend. So let's have a look at that backend now. The backend is built around the data coming in from this public API. So the public API is this here. And as I say, it's broken at the moment, unless it's going to pick up again during this demo. So it's from this particular endpoint here. There's no authorization needed. It's a public endpoint. It's open government licensed. And you can see here, we get a CSV dump back. You've got a header on there. And then you got a date, you got a time. So 2:29 this morning is when it kind of went bang. And then you got the different car parks, the capacity, the empty places, the latitude and longitude. So just useful information about car parks. It's not a particularly complex API, but it is a useful one. What we're going to do with this, since it's a series of events, we're going to stream this data into Kafka. And Kafka is going to become a store of these events that we're going to be able to use to process and drive alerting, to build state from that we can query, and also to pass on downstream to build out analytics. But Kafka becomes our platform around which we build these things. And I'll talk a little bit later on about why I've made that choice. So to get that data in, to get that CSV dump into Kafka, I'm actually going to use a little bit of a kind of a shortcut method. I'm going to say, well, we're going to take that output from the API. I'm going to strip off the header to start with, because that header isn't, so that in Kafka, a message is an event. So this particular here, this car park is reporting at a certain time, that's an event. Whereas a header line like that, that's not an event. That's metadata that we need separately, and we do need it separately. I'll talk about how we use it, but we don't want to put that onto the topic. So instead, we're going to do this. We're going to say, take the curl statement, take the API output and pipe it through tail. And tail is simply going to strip off the header. So it says start from the second row of data, and now we just have the actual data messages themselves. And then we pipe that through Kafka Cat. And if you know Kafka already, then you may be familiar with Kafka Cat. If you're not, then go and check it out. It's amazing. If you're not familiar with Kafka, then Kafka Cat is a useful tool to get to know once you get to know Kafka. It lets you pipe data in, lets you pipe data out. So here we're going to say take the data from the API, strip off the header, and then pipe that into this tool called Kafka Cat, which is going to produce it into my Kafka broker on this particular topic. -t makes it behave like a Linux T command, so it sends it to that thing, but it also echoes it to stand it out. So we get to see this is what it's just sent over to that Kafka topic. So now we've got a Kafka topic with this data flowing into it. So let's now head over to a tool called ksqlDB. ksqlDB, it's community licensed, it's developed in the open, it's part of Confluent platform, and it lets you write stream processing against your data in Kafka. So here you've got the little tagline, it says an event streaming database purpose-built for stream processing applications, and it lets you do two key things. It lets you do streaming ETL, and say I've got streams of data arriving and I would like to manipulate them and transform them and write them back onto enriched Kafka topics. It also lets you build state stores against your data, your streams of data, that you can then query directly. I'm going to do both of those here. I'll just flag up what it doesn't do is ad hoc analytics. It's not designed, just because it says SQL in the name of it, it's not designed for like, here's all my big data I've got in Kafka over like many, many years. I'm going to start doing ad hoc like data warehousing type queries. It's not designed for that. That's why you stream the data onwards and do that somewhere else. It's not designed for that. But for doing real-time stream processing, for building state stores that you can query within it, then it's perfect for that. So what we're going to do is we're going to say, let's create ourselves within ksqlDB an object that describes that data in Kafka. So the data in Kafka looks like this. Say show topics, we've got a topic called car parks. We can print that topic and it will say, I'll tell you what we're going to do. We're going to head over and we're going to take that curl output and we're going to stick it into a little loop, which says every 30 seconds, it's just going to dump data into the topic. So we get that kind of data flowing through. The API only refreshes every 3 minutes. So if I do it every 30 seconds or 10 seconds, we're just going to get duplicate messages. But for the purpose of this is kind of fun. So we're in ksqlDB. We're looking at the data in the topic, and we said print data in the topic, and it's coming through now. So we've got that data in the topic, and it's just raw data. Kafka messages are just bytes. Kafka doesn't care how you serialize that data. So that's our first task at hand, is to say, well, we've just got a bunch of like comma-separated values, which are actually not the easiest things to work with, because like commas here and commas there, like that comma there within the latitude, longitude, or within the URL, that's actually a bit fiddly because that's a comma, but it's not a separator. So let's get that data out of just like a big long string of comma separated, and let's apply a schema to it, because we're going to use SQL in a moment, and SQL needs a schema. So this is what we're going to do. We're going to say, let's create a stream called car park source, and here is our schema. Here is that metadata from that header row in that CSV that we got through previously. So we stripped that header out at ingest and we sent it into the topic. And I said, well, we need that data, that metadata, and we're going to use it later. Here's where we're going to use it. Here is the definition of that data in that source. It's got a date, it's got a time, it's a varchar, it's an int, it's a double, or whatever. It comes from this particular topic, and it's delimited. We could change the delimiter if it was tab or semicolon separated, but by default, it's comma separated. So now we've defined a stream on top of that data. We're not duplicating the data or doing anything like that. We're simply saying, here is this Kafka topic. I would like to read it in this way, apply this schema to that topic. And what it means is we can then query it. We can say, let's go back to the beginning of the topic. So set, offset, reset to earliest means go back to the beginning of the topic. Kafka stores data. When we write data into Kafka, it's stored, it's kept for us. So we can say go back to the beginning of that topic and then query the data. We're just going to select the first 5 rows of data, but now instead of saying what we did before, which was print topic, just like dump all the messages, we can say now apply a projection to that data. So we're saying select this field and that field and that field from this stream. The stream is just defined on top of that Kafka topic. It says, okay, here are the first 5 rows from that particular topic. And you can see here at this particular date and this particular time, it was for this car park and this is how many empty places there were. So we're querying Kafka topics. And we're doing so by having defined that schema on top of them. But we need to do a bit more than this with the data. So for example, if we look at that data, we've got a couple of string fields here. One's called date, one's called time. Now, you and I will eyeball that and say, oh, well, that's a date time field. And kind of like, I guess that we can use that for doing date time arithmetic and drawing time series graphs and so on. But to a computer, that's just like strings. We need to explain to it, here's how you model it, here's how you manipulate that data to make it an actual timestamp field. What's the time zone on it and so on. We also want to do a few other things. We want to take the latitude and longitude and create that into an object so that that can be used properly downstream. So this is where we do our streaming transformations. So that looks like this. I'm going to copy the thing in and then we're going to walk through it. All of this code, by the way, I will share afterwards. It's up on GitHub. You can go and check it out. So you can actually build this out. It's an open API. So you can build it out and run it for yourself if you'd like to. So again, we're going to say set the offset to the earliest, process all of the data in the topic. And now we're going to do a create stream again. Before, when we did create stream, we declared a stream on top of a topic. Now, creating a stream, and we're going to populate a new topic with the results of this select statement. In the relational database world, for many, many years, we've said create table as select. Create a new table with the results of this select against some others. Create one static copy of the data based on another copy of the static data from over there. In the streaming world, we can say create a new stream based on the continual output of a query against another stream. So we've got our car park events arriving in our raw CSV form. We're applying a schema to them. We're going to apply some manipulations in a moment, which I'll walk through. And as those events arrive from the source, they pass through that flow and get written out to a new Kafka topic. So that's what we're doing here. So let's see the kind of things that we're doing to it. We're taking that CSV data, those raw strings of comma-separated data, and we're saying, well, we've declared the schema. We declared the schema up here when we said create stream, and here is my schema. So we've declared that schema. Now let's persist it. We're going to say, write the new data out to a new topic and serialize it using protobuf. I could use Avro, I could use JSON schema, but we're going to write that data to the target topic, and the schema is going to get stored up in the schema registry. So when someone else comes to use that data, the schema is available to them. They don't have to go and eyeball it and kind of like type the fields in again and do sorts of stuff like that. We've got a schema to the data, we persist that schema, that makes our applications much more resilient and easier to evolve and develop across different distributed teams. We're saying let's take that date and time, let's get it into a suitable format, so let's apply a time zone to it, and we're actually going to turn it into a timestamp object. So in ksqlDB, it stores it as a big int, the number of milliseconds since the Unix epoch, but it's now a timestamp object. We pull in all of the existing fields, and then we also create an object to hold the location. So we're creating a nested struct here, so with the latitude and longitude values. We're doing a calculation. We say, well, as this data passes through, let's work out the percentage full of that data. So take this from that and cast it as a double and make it a percentage. So we can also create those derivations on the data as it arrives in the system. And then we're adding some lineage information. We're saying, well, this is the API from which the data came. I mentioned briefly earlier, this data is coming from a Bradford Council API. There are other car park APIs available, and it's a fairly standard entity definition. It's a car park, it's got a name, how many spaces has it got, how many are occupied. So we can actually get that same data from other APIs, and because it's the same logical entity, we'll put it on the same logical stream. And if time allows later on, I'll show you how to do that. If not, you can go and check out the full code online. So we're creating this stream. It's going to go and query this source stream that we created, that we declared on top of that topic. And we're now going to populate a brand new Kafka topic continually with all of the existing data that we've got in that topic, plus any new messages that arrive. So that's going to go and create that. And we can say show streams. And it says, here are the streams. We've got one called car park source, which is the original on top of that car parks topic. It's delimited format. And here's the new one we've created. By default, the Kafka topic is of the same name. We could override the topic name if we wanted to. The key format's just in Kafka, it's just a string. The value format, we've serialized the value as protobuf. I can say show topics, and you've got a topic here called car park events. That's the one that we went and created. We could have overridden the partition count, the replica count as well if we'd wanted to. It just sticks with some defaults otherwise. So if we say describe car park events, you can see here is the schema for it. You've got all those different values. You've got the existing data that came through, plus the new fields that we created, like location and percentage full. I could say select star from that stream. Let's say commit changes. And now you can see that data as it's arriving. So unfortunately, because the API is bust, you can't actually see the changes in the data. Like that time is just going to stick at 229 until it kind of unbreaks itself. But take my word for it, it does actually work. You can see it in the charts that I showed you. You can see it from a different API. If we get onto that later on, as new messages arrive from the source, they pass through this enrichment pipeline and onto the new topic. We can use that topic for doing lots of different things. That topic as it stands now is kind of like it's a cleansed set of data, an enriched set of data. We can stream that on down to Elasticsearch. I'll show you that in a moment. But first off, let me show you how we can use that data to actually build state within it. Because if you think of those stream of events, within that stream of events, you've got a key, which is the car park name, and you've got a bunch of events relating to that key. So you could say, well, for that particular key, what's the latest value for it? For that particular car park called Westgate, what's the latest value for like number of spaces available? So you get a bunch of different updates, but what's the latest value? What's the state? If we put this in a relational database and queried, like select spaces from car park where name equals Westgate, it would say, well, here is the state. That's what we store in relational databases. We store state. And from streams of events, we can do stream processing, we can do event-driven alerting, but we can also build state. So let me show you that. If I query that stream of events and say for this particular car park, again, we're using Westgate as the example, show me the events. Query that stream. It says, well, for this particular car park, here we've got the different events. They're all the same because the API is not changing, but you've got different events. So imagine the API is working. So you would have at 229, it was this. At 231, it was like 113. At 233, it was 110 or whatever. You've got events varying for that particular car park. But we can say, well, let's create ourselves a table. So in ksqlDB, you have two different types of objects. You have a stream, which is an unbounded series of events, basically like a Kafka topic, but with a schema. You also have a table, which is actually a Kafka topic with a schema, but the current state. So let's go and create that. We're going to say, well, let's process all of the data. So go back to the earliest point, create a table. We're going to use name as our key. So we do a group by name. And then we say, let's take the latest value by offset. So within the log, they've got an offset. Take the latest value for like capacity. We can do an average as well. So our aggregations here. We could do min, we could do max, whichever aggregation you want to use. So that's now building a table within ksqlDB. I can say show tables, and it says it's got a table called car park. The table is backed by a Kafka topic. So our Kafka topic is also called car park, but we've now got a table that holds state, but is built from a stream of events. We finish off. I was about to launch into a little aside about streams and table duality. It's really important, but I'll mention it later on. I don't want to get distracted from this. But what we can do now is we can say select the latest timestamp, the number of empty places currently, the average empty places from car park, from our table, where the name is Westgate. It says, well, this is the current state for that. And if the API was working, we could refresh the data, and it would say, well, actually, the state has now changed. But the point is we're doing a select against the table, and it says, this is the current state. It says query terminated. The other queries that I ran before, I said emit changes. Basically mean I'd like to subscribe to the changes as they happen within that stream or within that table. If I say emit changes, it's going to say, well, here is the state of that table. When the state changes, I will tell you about it. But it says down here, press Control-C to interrupt. Subscribing to a stream of changes in this way, which is also useful, but not necessarily what we want. Sometimes we want to look up the state For a given key, what's the current value? That's what we can do here against that table also. So from a basic stream of events, you can actually query state. We can query it from within ksqlDB. We can also query it from outside ksqlDB. So let me show you that. I'm going to take the same query that we ran before. Let's move that up to the top of the screen. I'm just going to use curl here. You could use Postman or whatever, or however you want to call your REST APIs. But here we're going to the ksqlDB server. So I've not got any other infrastructure here other than Kafka and ksqlDB and schema registry, but it's all built around that. There's no other external data stores. So this is potentially the magic moment for some people when they see this, because they assume, well, you're querying a state. So you're doing your stream processing, and then I guess you're sticking it in like a NoSQL store or a relational database for the application to query. Actually, what we're doing is we're saying, as these events arrive, we're going to manipulate them, and we can build and persist that state within ksqlDB. And ksqlDB is like, it's distributed and scalable and fault tolerant. So that then becomes your point from which your applications can query the state. So we're going against ksqlDB. We're running our SQL query, so select the latest timestamp, empty places, and so on from Carpack. We're typing it through JQ just to kind of like make it a bit more readable. Let's just do that and make the window a little bit bigger. So you can see our latest timestamp is a string, empty places, integer, and here are our particular values. There's 229. I'm going to get 16, 229, but we're stuck with it. But we can query from an external application. That's what we do in the Telegram bot. The Telegram bot, there's a community library for Go that hooks up to ksqlDB and lets you run queries against the state held within ksqlDB. We can also do event-driven alerts. So as well as looking up the state, we can say, I would like to subscribe to a stream of changes. So in this example here, we can say we're going to select from the car park events where, for a particular car park, it has some available spaces. Now, we all know this is definitely going to come back with something because all the car parks have got available spaces. But what we're doing here is, let's move this down a little bit, we're going to say set the offset to the latest, which means go to the end of the topic and tell me when anything changes subsequently. If we go back to the beginning of the topic, we would find out over time when this car park had available spaces. Instead, we're saying, as of now, tell me when it does have spaces available. So we run that, and next time we get data in from the API, we'll get a message over here. So I'm just going to trigger the API to refresh, just as keep things moving along. So we get data flowing into the system, it gets enriched, it gets passed through onto that target topic, and we should see any moment now data appearing onto the results of that query. So you can see the data's come through. There's good old 2:29 in the morning. It holds 611 cars. I've got 610 empty spaces. So we can run that query from within ksqlDB. And here's our emit changes. We say, I would like to subscribe to that stream of changes. We've specified our predicate, select our values, our fields from this stream of data where our predicate is true, emit changes. Anytime that predicate is matched based on an incoming message, so like we could be filtering a stream of system-generated events, and we've got an SLA for a particular error threshold. When the number of errors is greater than this, then send that particular message. And we can also use the REST API to query that same stream. So again, we're going to do this. Down here in Bash, we're going to use curl to call that same REST API, the same ksqlDB REST API, with our select statement. Again, emit changes. And if we try a little refresh, that's now subscribing to those changes. The data comes in, the data passes into the Kafka topic. The Kafka topic runs through the ksqlDB transformation and enrichment, and then from ksqlDB, it emits out to the calling client, which here is our Bash query, but it could be your own application, it could be the Telegram bot using the Go library. It says, okay, this particular event has matched our predicate, and it emits it out into that REST query output. That'll come through any moment now. It'll behave the same as it does up here. It's a live demo, so maybe it won't. The other thing that we're going to do is we're going to stream that data out into. Oh, it looks like the network's gone offline, so that's not going to work. Okay, never mind. So let's see what we could also do here in terms. Can someone just let me know if my audio is working? Because my computer's telling me that my computer's gone offline. I don't know if you're listening.
Yeah, I'm here. It's look, I think we have a problem with the connection, so one sec. Try again to share your screen.
Okay, I think we lost you, didn't we? Or you lost me.
Yeah, here we go. Something weird happened, so.
My computer started flashing up saying I had no connection. Okay, it looks like we're back. Can you all see and hear me okay?
I can. Let me just check the. Let's just check the chat real quick. Yeah, everybody can hear you. That was a bit weird. I just tried to check if it was on our end, so ready. Sorry.
No, I think so. When I woke up this morning, my internet was offline, so I think it's just. I don't know if you can hear the building work happening next door. Apologies for all the noise, but it's the joys of presenting from home. Right, let's a quick recap, because I think I lost you just about here. So I showed you how you can do what are called pull queries, where you can query externally against the state held within ksqlDB. And we showed doing that using the REST API. This is what are called push queries. So I didn't use that word a minute ago, but push queries are where we're subscribing to a stream of changes. So a push query looks like this, where we're saying from this particular stream of data, match this particular predicate, and then send the changes to the user. And we can run that from within the ksqlDB interface. We can also run it using the ksqlDB REST API over here, and the client will receive that stream of changes as the data varies. So now the last thing to show you is actually how we can take that data from within Kafka and stream it over into Elasticsearch. So we can stream it to any number of places. I'm just using Elasticsearch as an example. And this is actually one of the great things about using Kafka, because you can use the same data to satisfy multiple different requirements. We've taken that CSV data and we've set the timestamp and we've serialized it in a sensible way to store the schema, and we've built an object out of the latitude, longitude. We've done a bunch of common transformations to that data, which now multiple people can benefit from. So the application that we came along to build with a Telegram bot showing when things have changed and so on, that is satisfied by this data that we've created. But other teams may well also want that data. So other teams might want to build analytics against it or do data science queries against it. Wherever they want the data, we can provide it from Kafka. And because Kafka stores data, that same data can be made available to multiple different targets completely independently. We don't start building tight couplings together saying, well, for this project here, we built a one-to-one connection. And now if you want that data, you will have to hook into that place that we put it. So we're going to put it into a database because that's what our application needs. You can now query our database. And then someone else can query you, and then someone else can query you. We'll build a kind of like a nice little spaghetti big ball of mud. Instead, we say, well, an event happens, so we stream it into Kafka. And from Kafka, we can build multiple loosely coupled systems that can each evolve at their own rate. So here's an example of how we can take the data from Kafka and stream it down to Elasticsearch. I'm going to use Kafka Connect. So we're going to say we're going to take the data from this particular topic, and we're going to stream it down to Elasticsearch. So ksqlDB acts as a wrapper around Kafka Connect. You can use Kafka Connect directly as well if you want to. So we go and create that. We can say show connectors. And it says we created a connector and it's running, which means that if we then go and open up Kibana, and say, here's Kibana on my local machine, we can also kind of like cheat and go and open up Kibana. So I've got another version of this, a parallel version of this that's running up in the cloud. On my local machine, it's all on Docker Compose. And we can say, let's kind of take that data and go and have a little look at it. And so we're going to filter it based on timestamp. And we can go and start and analyze it. You can see here in the last 24 hours. So it's all based around 229, obviously. So you can see here, you've got 229, we've got lots and lots of data that have come in from that source. So there's our name, there's our latitude, longitude, but also down here, if I zoom in on that, down here is our location object that we built as a result of that transformation. So the point of using Kafka is it can be as much or as little as you would like it to be. It can be a simple message broker between applications, just like the data comes in, the data goes out, like pub sub, nothing much more than that. But it stores the data so you can reuse it, but we can also apply those transformations. We can do simple lightweight stuff like say, as the data comes through, build these two fields into an object, write it out to a new topic, and then on it goes. Or we can start to do much more complicated stuff and filtering and aggregating and all sorts of things like that. So we've got the data in Elasticsearch, and we can also build that out into a more functioning dashboard. We can use that latitude, longitude information to start to build maps against it. We can chart out over time. Let me talk a little bit more about how and why we've built it this way. And I like doing live demos, but I'm aware of time, and it's also interesting and appropriate to understand what's actually happening underneath the covers here and like, why are we even doing it like that? So if my cursor works, we can see here. So this is kind of what we've built out. This is what we've built out. We've said we've got a source of data coming in from an external API. So the Northern Data Hub is where this data comes from. We're going to pull it in to Kafka. Now we set up a little shell script to ingest it, but we could use a connector to pull it in. We could write an application to pull it in. But as something happens in our world, that event, we produce it into Kafka. From there, we took that car park information and we used it to drive a bot in Telegram with a Go backend. We also took that same data and streamed it over into Elasticsearch. Some of the key patterns here that I want to kind of flag up and kind of draw your attention to is being able to do event-driven alerts. So instead of an application having to pull a backend and saying, like, has something changed? Do I need to send an alert yet? We can say, well, as something happens, we look at it, we evaluate it for a predicate, and if it matches that predicate, then we can send an alert. So we can say, as a car park tells us that it's got this many spaces available, is that spaces available greater than the threshold that would set? If it is, then that message passes through the pipeline and on into the alerting application. We can build state, we can build key value lookups through basically a materialized view based on these streams of events. Now, if you think about the data that we work with, almost all data starts life as an event. It's just a lot of the time it quickly gets shoved into a database or a NoSQL store, but data starts life as events. And the closer we can keep what we're doing with the data to events, a lot of the time the easier life becomes. Kind of like the friction is lower, the impedance mismatch is lower. So we've got a stream of events. We can say, well, as those events arrive, we're going to define an aggregation against them, and we're going to persist that aggregation within ksqlDB. So ksqlDB is driven by the data in Kafka. It reads data from Kafka, it writes data to Kafka. It also persists internally in its own data store, the aggregates that we define. So we define this aggregation against the data, this materialized view, and then that materialized view can be used to satisfy these queries from external applications. So our user says to our application, how many spaces are there? The application can actually run a query against that data within ksqlDB to find out that information. It's just a pull query, it's a static query. It says, what's the current state? It pulls that out of the materialized view, and it passes that back to the application and passes it back to the user. Another really important thing that we did was we thought about schemas. Now, if you work with Kafka, I implore you, give a lot of careful thought about to how you serialize your data and to how you deal with schemas. Because this is one of those things that people sometimes opt for like the easy path, like the least friction path, and there are seemingly no dangers. Except 6 months down the line, it turns out there's lots of kind of like goblins and gremlins in wait to kind of like jump out on that supposedly easy path. Because if you don't have an explicit schema for your data that's enforced when the data is written, that's available to consumers to read without even having to phone you up or send you a message on Slack to find out what it is, if you don't have that, things get messy. So the data that we worked with to start off with came in as a lump of CSV, just a bunch of strings with like commas separated. And so our consuming application looks at that and says, like, well, okay, I guess I'm going to have to start parsing that. I guess I'm going to have to go back to whoever wrote that data and find out the spec for it and like how many fields should there be and what are the data types. I'm going to have to handle those date time things and concatenate those. And each consumer has to start from scratch with that data. And if you say, okay, well, we're producing that data and we're not using CSV, we're going to like use something else, you're now coupling you and that consuming application together. And it might seem obvious, but as systems evolve and grow, it becomes less obvious. And then you go on holiday and someone else makes an incorrect assumption about that data and things get brittle. So instead we say, we're going to take that data and we're going to serialize it explicitly with the schema. We're going to start as Avro, as protobuf, as JSON schema, as an appropriate serialization format that our consumers can read and get the schema directly. So now our consumers can go and read that data and work with it without even having to go back to the team who wrote that data and say, like, are there fields missing? Is there a default? Like, what's this thing here? They know that already. So you can now build things in much more loosely coupled and agile fashion. We use ksqlDB to apply that schema to the data, because at some point you've actually got to go through that hard work of applying the schema. But the point of doing it this way is we do it once, and then all of our other applications can make use of it. And if it's just one application, that's fine. But now as other ones come along, you benefit from that transform once, use many times idea. So we say, well, the data comes in and we declare that schema. We use that header information that came in the CSV file. We go back to the kind of like the data design documents and say, what is the schema for this data? And we declare it explicitly within our ksqlDB statement. Create a stream on top of this topic with a schema. And then we re-serialize that data onto a new Kafka topic. You say, create a new topic on Kafka. And we could just say, select everything from this inbound stream, but serialize it as protobuf. Serialize it as Avro. In the demo I showed you, we did two things together. We serialized it in a different format and we applied transformations, but you don't have to. And this comes back to the point I was making before. You can use ksqlDB and stream processing for as much or as little as you would like. It doesn't have to be like, we're going to do like big, fancy, all-singing things. It could simply be, we've got this data coming in, we want to apply a schema. We've got this data coming in, we want to concatenate a couple of fields. Stream processing is exactly what that's for. The last thing that we saw was building out integration. Saying we've got data coming in, we've got data going out. So to get the data in, we actually wrote a little hacky shell script. But probably better would have been to kind of find an appropriate connector. Reading the data in our application, we use the consumer API for that, and our application consumes it directly. But pushing that data from Kafka down to a target system, we use something called Kafka Connect. We could write an application to go and use the consumer API and read from Kafka and push it down to the target system, but that'd be a bit silly because there exists an integration API within Apache Kafka already, and it's called Kafka Connect. So with Kafka Connect, you say, well, I've got data coming in from a bunch of places or going out to a bunch of places, and you plug and play whichever connector you want to use to get that data into Kafka or get the data out to Kafka. And it's just configuration based. So we saw within ksqlDB, you can call it even using a SQL statement. If you don't want to use ksqlDB, you can use just a REST API against Kafka Connect or there are web interfaces to specify your configuration, a lump of JSON, get the data from here and go and put it in there. So then we can build out our analytics on top of it, and it's all good. So again, why are we actually doing it this way? And these are some interesting design patterns that I've talked about, some really useful things to take away and apply. But do we even need to use Kafka in the first place? Why not just like shove it all into Postgres? And you could totally do that. And for something that's kind of like low volume, we've got like a few API updates per minute, that's probably fine. And it's a little project I'm building on my laptop, like, why not? point of all this is to think about the type of data that we're working with. The type of data that we're working with is events, or rather streams of events. So we've got streams of events as our raw source of data. So let's think about how can we work with that in a way which is going to mesh with it in the best possible fashion. What are the characteristics of what we want to build against those streams of events? Why do we even care about it? We want to react to things as they happen. We don't find out last week what happened in the kind of the car parks the week before. We want to find out as something happens, we want to react to that thing. We've got people driving around the city, they want to know as and when a space becomes available. But we've also got people driving around the city wanting to be able to say how many spaces are currently available. What's the state? What's the current state? And that state is manifested from a stream of events. A stream of events is what we can materialize up into state, and we can query that directly. We also want to have the latest data to drive our analytics. And with analytics, sometimes people say, oh, well, who cares if it's a little bit out of date? But if you've got a live source of data, why not use it to give people the latest view of the analytics? If they only want to look at it once a day, that's absolutely fine. But you find more and more people are saying, well, I want to know the state of the business as of now. And that's where the events come in. So let's have a quick, in fact, no, I'm going to skip through this because I want to do some questions if people have them. I was going to do a quick run through of Kafka. I'll share a link on the Slack channel afterwards with a few videos for primers into Kafka. But let's skip through that now, if I can find my slide navigator. And quick talk briefly about ksqlDB, because I've talked about that. It's something that people may be less familiar with. With ksqlDB, we're consuming data from Kafka. It's basically a consumer for data in Kafka, and it writes data back into Kafka also. So we consume data, we write data back into Kafka, and we process it. Whether that's joining columns or serializing the data or filtering it or aggregating it, we process the data in there. We write it back onto a new Kafka topic. We can reconsume that data. We can daisy chain our transformations. It might be that we want to apply one transformation which is going to apply to any user of the data. There's known bad entities within the data. Let's just filter those out. No one wants to know about those. Whereas other transformations may be much more specific to a particular process. So to apply that up front would be erroneous. You want to make sure that you apply it at the appropriate point. So you can daisy chain your transformations. That data we can push down to other platforms for analytics. We can stream it to S3, stream it to Elasticsearch, to a database using Kafka Connect. But those same Kafka topics we can use to drive our applications, our microservices that can subscribe to these streams of changes, these Kafka topics, to drive what they're doing, to kind of do things like alerting. But we also saw how ksqlDB can persist state. It can build a materialized view. So you can say, for a bunch of bank account transactions, sum it up by account ID. So that was the current value for a particular bank account. And then our external microservice, our external application can say to ksqlDB, using a REST call into it directly, what's the current value for account ID 42? It says, well, the current value is, the current balance is 94. So that could be with the REST API. There's also a Java client natively within ksqlDB. There's a Go client in the community, a Python client. So however you're writing your applications, you can actually integrate into ksqlDB directly. ksqlDB itself runs separately from the Kafka cluster. So you've got your Kafka cluster of brokers. ksqlDB runs separately. It runs within a JVM. It's actually built on top of Kafka streams. So you don't have to use ksqlDB. Everything that I've shown you here with ksqlDB can also be done with Kafka streams. So Kafka streams is part of Apache Kafka. It's a Java library. So if you would rather use your stream processing that way and interactive query and things like that way, you can do so. You can run ksqlDB anywhere. It's just a JVM process. You can have it in Confluent Cloud, and it's provided as a managed service there. You can also run it yourself, like it's a Docker process or Kubernetes or bare metal, or however you want to go and do it. It's just a JVM process. So quick thought again about why are we even using Kafka? We're using it because we have streams of events that we want to work with. Data begins life as an event. So we're going to handle it as an event. We're not going to kind of thrust it up into state before it's ready to be that, because we want a stream of events. Because we want to process that data. We want to filter it, we want to enrich it, we want to transform it. We want to store that data, and build out state that can be queried. And we also need to integrate that data out into different systems. So using Kafka, we can do event-driven alerting from our applications. We can do key value lookups from our applications. We can also build out streaming ETL processes using ksqlDB, using Kafka streams. So hopefully this has been interesting. Apologies for the building work noise next door. Apologies for the internet glitch. That's the fun of remote conferences these days. Hopefully you would like to learn a little bit more about this. Go and try it out for yourself. I'll share all of these links on Slack. I'll share them all on Twitter. So you can go and try it out. As I say, the API is an open API. It usually works. This is the first time I've seen it fail. So you can actually just go and start polling that API and see what you can do with that data. All of the code for the Telegram bot is on there also. All you would need for that is your own API key, and off you go. You can go and try out Confluent Cloud. There's a bunch of codes and stuff like that that gets you money off your cloud bill for the first few months. So go and give that a try. That gives you a managed Kafka service. It gives you managed ksqlDB and also managed Connect. There's a great place to go and get a little more resources for learning more about Kafka. So developer.confluent.io gives you the ability to kind of go and look at podcasts and tutorials and blogs and all sorts of useful stuff like that for learning more about Kafka and Confluent Platform. So with that, thank you very much for coming along. And I'll head over onto Slack. I'll close down my screen share and head to Slack now and see if there's any questions. And if you want to unmute yourselves and ask that way, that's also fine. Okay, no questions. Anyone want to ask in real time or unmute themselves? That's also fine. In fact,
Robin, can I ask you a quick question? Great talk, enjoyed that very much, thank you. The question was, ksqlDB, is that where the materialized views and stuff going on there, is that storing state kind of inside ksqlDB, like kind of caching the view and stuff, as well as on top of the Kafka stuff, kind of as well as Kafka itself?
Yes, exactly. So, no, total sense. So let me just show you here. So within ksqlDB, so there's a couple of talks. So if you go to talks.armoff.net, there's one about ksqlDB, which goes into a little bit more info, and then the Confluent blog also. But basically, it's this kind of thing. So ksqlDB has got RocksDB within it. So it uses RocksDB for that state store. But exactly as you say, it also uses Kafka topics for persistence. It uses Kafka topics as a change log for changes made into RocksDB. So it's entirely fault tolerant and resilient. So if you lose one node of ksqlDB, it can actually build that state elsewhere.
Awesome, thank you.
Great. Have you tried ksqlDB already?
I haven't. I know some of my colleagues have played with Kafka a little bit, so I haven't personally used it, and I'm now inspired to go find some other open API. That unfortunately my local council doesn't have car park data available, so I'm going to go find something else and do a similar thing.
So I did a talk, it's a shameless self-promotion, but let me show you on here. So I did a talk at a Kafka meetup earlier this week. So talks.armoff.net. So there's a couple of examples. So this was using network rail data. So you can go and check this out. And this goes into using the network rail API to kind of like do a bunch of movements around the train network. Again, similar kind of thing. It's like data coming in from, in this case, it's ActiveMQ. But it lets you build out, again, you can tell I like Elasticsearch, but a useful front end for that, and you can do like alerting and so on. But that's got tons of Kafka and ksqlDB, and also, again, with an open API.
Cool.
Any other questions? We've got 2 minutes. I'll post all of the slides and a bunch of other links and stuff like that onto the Slack channel. But more than happy to answer any questions now also if anyone has them. Otherwise, enjoy the rest of NDC, and thanks for coming to my talk.